Okay, good morning everyone. So for today, please join the link. Okay, please click the link that I just gave. Okay, and also enter the code. Okay, as usual. So for those who just enter the class, this is the code, and this is the link, and also the code. So it should be 34. Okay. Okay, good, very good. So all of you already joined the class. Okay, so let's start now. Okay, so today we will learn about the diffraction of wave. Okay, so there are actually four types of phenomenon of wave. Okay, so the first one that we already learned is a reflection of wave. Okay, and the second one is the refraction of wave, and the third one is a diffraction. Okay, that we will learn later. Okay, and another one, the last one is the interference. Okay, so this is the four types of phenomenon of wave. So let's see what is actually a diffraction of wave. Okay, so here it says diagram below, okay, shows two walls which are built near the shore. So compare the pattern the water wave before and after passing the gap between the two walls. So what is the function of the walls? Okay, so you can see here before it passed through the wall, the wave is like a plane wave, right? So when it passed through the wall here, okay, the slit, the gap here, okay, it will produce the semicolor wave. Okay, so it become like a semicolor wave. Okay, right. So let's see the video. Okay, so you can see it's formed like semicolor wave here. Right. So this is actually the uh diffraction. Okay, diffraction of wave. Okay, what is a diffraction of wave? Okay, so diffraction of wave is a phenomenon in which waves spread out or bend as they pass through a gap or around a small obstacle. Okay, so it's like a spreading. The wave is spread out, okay, as they pass through the gap or around a small obstacle. Okay, so here let's say this is the wave. Okay, so when you pass through the gap here, so the wave will be spreading out like this. Okay, so it will be spread out. Okay, so this we call it as the diffraction. Okay, so let's see this video.
When the gap size is approximately equal to the wavelength, the wave pattern after passing through the gap is circular. When the gap size is bigger than the wavelength, the wave pattern after passing through the gap is less circular. The wave
Okay, so this is what happened when it passed through the small slit and also the bigger slit, right? So the next one, observe the wave when they meet a barrier. Just now it passed through the slit. Okay, now it passed through the barrier. Okay, or the obstacle.
the waves when they meet a barrier. What happens if the length of the barrier is larger than the wavelength? The waves bend around the edges and fill up the space behind the barrier. A shadow area is formed behind the barrier. When the size of the barrier is smaller or approximately the size of the wavelength, the diffraction pattern of the waves is more obvious. When the size of the barrier is larger, the shadow area is larger. The diffraction pattern of the waves is less obvious.
A smaller obstacle means the effect of the diffraction, okay, will become obvious. Okay, will become obvious.
Observe the waves when they meet.
Okay, so now it says this is, let's say, the experiment. Okay, so this is the ripple tank, right? So this one, if we have in the school open, we can go to school. So we will do this experiment, okay? And also with the reflection and refraction also, and also the interference, okay? So we use the ripple tank, okay, to see this four phenomena. Okay, so this is the example of the diffraction, right? So you can see it produced the plane wave here, okay? But when it passed through the slit, right, the wave, okay, the wave spread out, and also it formed the circular wave. Okay, so that is called as the diffraction. Okay, so this one you have to draw. Okay, we have to draw the diffracted wave. Okay, so what is the difference when it pass through the wide gap and also the narrow gap, and what the difference when it pass through the small barrier and the large barrier? Okay, so for the wide gap, okay, for the wide gap, what you have to do, the first one, you have to do this line first. Okay, so here when you pass through the wide gap, okay, of course, the effect of the diffraction, okay, the diffraction will become less obvious. Okay, so what you have to draw, you just draw the line like this. Okay, and one more thing, okay, the wavelength before and after the diffraction, it must be same. Okay, it must be same. Okay, because for the diffraction, the wavelength, the speed, and the frequency, okay, is same before and after the diffraction. Okay, is same before and after the diffraction. It's just same like the reflection. Reflection also the speed, the wavelength, and also the frequency is same before and after the reflection, right? So diffraction also same, okay? The speed, the frequency, and also the wavelength is same, but the amplitude or energy, okay, is decreasing, okay, before and after. If we compare, before is higher than after, okay? So here when you draw the wavelength, okay, when you pass through the wide gap, okay, so you have to make sure the wavelength before and after is same. Okay, so this is the diffraction. Okay, when it pass through the wide gap. Okay, this is the diffraction is less obvious. Okay, so what happened when it pass through the small gap? So when it pass through the small gap or small slit, okay, so again we draw the line like this, okay, and it will be a circular, okay, it will be a circular like this. But again, make sure the wavelength before and after must be same. Okay, for this one, it will be more obvious. It will be more obvious. The diffraction of wave will become more obvious. Okay, so this is what happened when it pass through the wide gap and the narrow gap. Okay, the next one, what happened when it pass through the small barrier? Okay, what you have to do, the small barrier here, you draw the line, okay, like this. Okay, and then you draw the wavelength here. right? It become like this. Okay, but for this one, okay, so this is how you draw for the small barrier and the large barrier. So you draw the line first, okay, and then after that you draw the wavelength. So you will know when you will start to draw the when you will have to stop to draw like this, okay. So now all the wavelength will be connected like this, okay. So this is the how to draw the diffracted of wave, okay. Alright, so now it says compare the wavelength of wave before and after passing the gap. Okay, so this is when the small gap and also when there's a bigger gap. So the wavelength should be same. Okay, before and after it passed through the gap. Okay, so it must be equal. Alright, so what happened? What can you say about the direction of wave after passing through the gap? Okay, so you can see it will be spread out. Okay, you can see all the wave is spread out. Okay, and for this one also it will be spread out like this, but it's not that obvious if we compare with the small gap, right? Okay, so for now, what I want you to do, I want you to draw, okay, the wavelength, okay, after it pass through the small slit and also the bigger slit here, okay, the narrow and the wide slit. So make sure the wavelength is same before and after the diffraction. Teacher, I suddenly quit. I tried to join now. So I will remove your name here, okay? Yep, Jun Hin. Who is 27989? Why you put your name as a number? 27989, who is it? Okay. Some of you already submit. Good. Okay, 10 more student. Jensen, Ziying, Shunhin, Jayu, Yvonne, Caroline, Tongzun, Yumin. I haven't joined yet rigging. Okay, teacher, I certainly joined with two status, so teacher can check this one. Okay. Wait. You use different name, is it? I don't know which one should I kick because you put the same name. Yeah. So which one? The top one. Okay. Juhin, you didn't join yet. Okay. Caroline? Where is Caroline? Okay. So let's check your answer here. Okay, so this is a small gap, right? So you have to draw the line like this. Okay, so the wave that produces should be a circular wave, right? Okay, and this one have to draw a line like this. Okay, but the line it should be like this. Okay. Oh, all right. Okay. Make sure the wavelength is same, okay, before and after. I know maybe this one is hard for you because you draw using the mouse, okay? But in paper, make sure you, when exam, make sure you draw it with the same wavelength. Okay, before and after have to be same wavelength. So you can just measure. Okay, now what happened when we pass through the barrier, okay, or the obstacle? So you have to draw. Hmm? Okay, Aisyah, Liying, Nikki, Siobhan, Yang Yang, Ziyin, Hang Zhen. Ni, sini. Wait, can you answer this one? Okay, good. Alright, so let's see how to draw, okay, when the wave pass through the obstacle. So you just have to draw like this. Okay, so the wavelength before and after should be same. Okay, and for this one, okay, so that is the, okay, very good. Junkiat. Right. But later in exam, if they ask you to draw, make sure the wavelength is same before and after. Okay. Okay, for this one, make sure you draw the line first, so you know when you need to draw the full wavelength there, right? Mm-hmm. Okay, this one is like this one is like this. Okay, this one. Okay, sorry teacher, like this now. Okay. Alright, so state the changes to the incident wave that occur after passing the gap. So I think I already told you just now, the speed, the frequency, the wavelength is same, but the amplitude or the energy is decreasing, okay, after it passed through the gap or the obstacle, right? So the wavelength should be same, the speed should be same, okay, the direction will be spread out, okay, while the amplitude will be decreased. So amplitude is actually is equal with the energy of the wave, okay, with the energy of the wave. Okay, why the amplitude of the diffracted wave decreases? Okay, so the diffracted wave is spread out to wider area. So you can see it being spread out to the wider area here. Okay, so when it's spread out to the wider area, the energy will be reduced. Okay, so the amplitude will be decreased. So this one to study the factor which influence the diffraction of water wave. Okay, so the first one we study about the factors. The first factor is the small gap. Okay, so when you pass through the small gap, okay, it will produce the circular wave. While the when you pass through the bigger gap, okay, it will be bent and plain and bent at the edge. Okay, at the edge there. So this one you can see for the small gap, the diffraction is more obvious if we compare with the bigger gap. Okay, then how about when you pass through the small barrier and the bigger barrier? Okay, for the small barrier, okay, there is a small space, right? There is a small space behind the this one, okay. There is a small space behind the barrier, okay. While at the bigger barrier, there will a bigger space, okay, bigger space behind the barrier. So it means for the smaller barrier, okay, the diffraction is more obvious, right? While the bigger barrier, the diffraction will be less obvious. So what is the relationship between the shapes of the diffracted wave and with the size of the gap? So the smaller the gap, the more circular the diffracted wave. Okay, so means the diffraction, the effect of diffraction, okay, will become more obvious. Okay, while they pass through the, say this is the, so here this is the gap. We use a small gap. Okay, so sorry, this one is actually the wavelength. Okay, so study about the wavelength. So it says here describe the pattern of wave with different wavelength after passing through the gap of same size. So this one they use a same size of gap, but they increase the wavelength. Okay, so this one they use a small wavelength. This one they use a bigger wavelength. So it will produce the plane and bend at the edge. Okay, but if they increase the wavelength here, okay, they produce the circular wave. Okay, so here we already know that the first factor is the size of the gap. So the smaller the size of the gap, the more obvious the effect of the diffraction. And the second one is the size of barrier. The smaller the size of the barrier, okay, the more obvious, okay, the effect of the diffraction. Okay, and then the third one is the wavelength. Okay, so the higher the wavelength, okay, or the bigger the wavelength, all right, the more obvious the effect of the diffraction. Okay. So what is the relationship between the shapes of the diffracted wave with the size of wavelength? So the longer the wavelength, the more circular the diffracted wave. So it means that the effect of the diffraction is more obvious. Okay. So state the two factors that make the diffraction more obvious. Okay. So the first one is the gap, okay, or the barrier. Okay, the smaller the gap, okay, the more obvious the diffraction. Okay, and then another one is the wavelength. The longer the wavelength, okay, the more obvious the diffraction. Okay, so there are two factors, okay, with the this one, the gap is actually same as the barrier. The smaller the barrier, the more obvious the effect of diffraction, right? Okay, so the first one is a small gap or barrier, okay, and the second one is the wavelength. Okay, so if you want to see the effect of diffraction more obvious, you have to increase the wavelength. Okay, so this is actually the summarize. Okay, so what happen if you fix the wavelength, okay, but you use the different size of gap. Okay, so this one, if it's a wide gap, it will be less obvious. If you use a small gap, it will become more obvious. Okay, and then this one, you just use the fixed size of slit. You just use the same size of slit, okay, but you change the wavelength. If you use the short wavelength, okay, the diffraction will be less obvious. It will just produce like this, okay, like in the diagram here. But if you use the long wavelength, okay, then we produce the diffraction will be more obvious. So the wavelength will become more circular. Okay, the next part is the first one. Now we already study about the diffraction of water wave. Okay, so all that is actually for the water wave. Okay, now we will learn about the diffraction of sound wave. Okay, so diffraction of sound wave, the first one is said the audible sound wave have wavelength in the range 1.5 cm to about 50 meter. Okay, light wavelength have wavelength in the range of 4 until 7 times 10 power of negative 7 meter. So a radio is placed nearby a corner of a wall. So the radio is turned on, right? So this one, they compare the wavelength of sound wave and also the light wave, okay? So the wavelength of the sound wave you can see is higher than the wavelength of the light wave. Okay. So the first one asks you to compare the wavelength between the sound wave and the light wave. So we already know just now, okay, the wavelength of the sound wave is higher, right? It's 1.5 cm until 50 meter. But for the for the light wave is 4 until 7 times 10 power of negative 7. So it's very small, right? So here the wavelength of sound wave is higher. So can you see the radio? Okay. And what inference that you can make about the diffraction of light wave? Okay. So when you stand at the corner, so of course you cannot see the radio because the light is difficult to be diffracted. Okay. So why this is happen? Okay. So if we compare the wavelength of the light wave is very small. Okay, and we know the effect of diffraction. Okay, if you want the diffraction to occur, okay, you must use the higher wavelength. Okay, but since the light wave, okay, the light wave, okay, is very small, the wavelength, so the effect of diffraction is less obvious. Okay, so that's why we cannot see. Okay, we cannot see the radio because of the wavelength. So you already know the factor that affect the diffraction is the wavelength and also the size of the slit. So for this one, we use a wavelength to compare. Okay, so if we compare, is the wavelength for the sound is much higher than the wavelength of the light. So the sound will be more diffracted, okay, than light. So here, why we cannot see the radio? Because of the wavelength. Okay, so here, can you see the radio? What inference you can make about the diffraction? So cannot see the radio, the light difficult to be diffracted. Okay, can you hear the sound? What inference you can make about the diffraction of the sound wave? Okay, so here what you can see, you can hear, yes, you can hear the sound of the radio. So the sound can be diffracted. So relate the wavelength with the effect of diffraction in order to explain why we can hear the sound of radio placed nearby a corner of a wall, but we cannot see the radio. So here, because sound waves are more easily diffracted because if wavelength is longer than the wavelength of the light. Okay, so you have to remember the factor of the factor that affect the diffraction, the wavelength, and also another one is the size of slit or barrier. And this is to study the diffraction of light wave. Okay. So here what they did, they use a laser pen. So the laser pen usually there will be a red, green, yeah, yellow, blue. Okay. So here it says direct the laser light ray through a single slit. Okay, so it passed through the single slit here. So then you have to observe the pattern form on the screen and draw the pattern. So now we have, after that, you have to repeat, okay, using a single narrow slit and a small pinhole. Okay, so this is the video for the experiment.
This is a demonstration of single slit diffraction. When a laser beam This is I'm putting my hand in the beam here. This laser beam is incident on this circular dial that allows me to dial in the width of a slit through which the laser beam passes. So it's passing through this slit of various widths that I'll show you, and then having passed through the vertical slits, produces a pattern on the screen here. So the
Okay. So here is what happened when you put the laser, okay, and you make it pass through the single slit, right? So you can see there is a bright fringes, okay, the bright fringes, the dark fringes, the bright fringes, the dark fringes, okay. But at the center here, there will be a bright fringes, okay, very bright dark fringes, okay. This one they use a green laser, okay. So later, you have to compare what happened if we increase the size of the slit, okay. So that one we see later in this video.
the width, and what you see in this pattern is a central bright spot and then dimmer spots to either side. This is called the M equals 0 maximum, the M equals 1 on either side of that, M equals 2, etc. With a constructive or destructive interference, namely a dark spot at the edge of each bright spot. So this is for a slit width of 0.02 millimeters.
Okay, so now they use the 0.02 millimeters. Okay, the size of slit.
If we move to 0.04 millimeters.
Okay, now they move to 0.04. So 0.02 to 0.04 means it increased the size of the slit, right? So when you increase the size of the slit, what happened to the bright fringes that at the center here? So you can notice it's become smaller, right? It become smaller.
Millimeters. What you see is a pattern that's tighter with bright spots that are less wide. So as we increase the slit width, this is 0.08.
Okay, now it's using 0.08. Just now 0.02, 0.04. Now it's using the 0.08. So here you can see it becomes smaller, right? Okay.
Pattern gets even tighter. And then for 0.16, a pattern that's very, very tight. We can also do the same with circular apertures.
Okay, so this one, if they use a circular aperture, so what happened? Okay, they produce the bright fringes here at the center here. Okay, the bright one.
So this is a circular, instead of being a slit through which the laser beam is pointed, this is a circular aperture. The laser beam is incident on a hole and blocked from passing outside the hole and only goes through that hole. And what you see here is a pattern with a central bright spot in the middle, but then rings around it that are reminiscent of the dots that appeared in the single slit pattern. This is a very important pattern, the pattern produced by a circular aperture, and it's important in resolving stars and has relevance to the Rayleigh criterion, where you have a central dot that to resolve two stars, you have to take into account this diffraction pattern from the aperture. This is a smaller aperture. The earlier aperture was 0.2 millimeters, and this is 0.4. It may or may not be visible on the camera. It's a very, very small diffraction pattern from that circular aperture. So that is
Okay, so that what
diffraction
happened
patterns
when you
from
pass
single
through the
slits and circular apertures.
right? Okay, now you see the next video. Okay, shining a laser through a small slit. So they use a red laser. Just now we used the green one. Okay, now they use a red one. Okay, so you can see the center here. At the center here, there are the size of the fringes, right? It's very big. Okay, so it's increasing the size of the slit. So you can see the bright of the fringes become smaller. Okay, at the center here. So the slight width increasing, you can see the size here become smaller. Okay, if you increase the size of the slit. Okay, and also you can see the number of the bright fringes and dark fringes increasing. Okay, so this one when the slight width decreasing, so you can see the center, the size, the bright fringes at the center here increasing. Okay, so this one if they use a pinhole or so they use a yellow one. Right, so this is the center here. Okay, very bright one at the center. So this is what happened when you pass through the a pinhole. Okay. Okay, so narrow slit, right? Wider slit. Okay, and this is what happened when they pass through the pinhole. Okay, so the black and the bright lines alternately. So brighter in the middle. Okay. So this is, they say they ask you to draw. So you have to draw, okay, at the middle here, there will be the brighter, the bright fringes, okay, at the center here. Okay, then this is what happened when you increase the slit. You can see the size of the bright fringes at the center here will become decreasing. Okay, so single wide slit, very bright light in the middle. Single narrow slit, dark and bright lines alternately, brighter in the middle. Okay, so here it says the experiment. Okay, the experiment is repeated by using a pinhole. Okay, so what happened? Okay, when the light passed through the pinhole, so the light will be diffracted. Okay, the next one, to study the application of the diffraction of water, light, sound wave in daily life. Okay, so the first one for the water wave. Okay, so we build a pair of barriers. Okay, built to protect the housing area near a beach. Okay, so this one, let's say we know that when the wave, okay, when the water wave travel right from the sea water, okay, near of the beach, okay, so they bring an energy also. So the energy is quite high. Okay, so there must be a way for there must be a way to decrease the energy. So they build the barrier here, okay, a pair of barriers. So then after when the water wave pass through the barrier, okay, the diffraction will occur. And we already know, okay, one the characteristic of the diffraction is after it pass through the barrier, the amplitude will be decreased, mean the energy will be decreased. So when the pass through the barrier, the water wave, the energy of water wave will be decreased. Okay, so this is for the, let's say if they want to build the house, okay, near the beach, so this is the method they use. Okay, they build a pair of barrier to decrease the energy of the wave because of the because when it pass through the barrier, the wave will be spread out. So means the energy also will be spread out. So when the energy being spread out means the amplitude will be decreased, and it means the energy also will be decreased. Okay, so the amplitude will be decreased. And by relating the size of the wave with energy, explain how the erosion effect the beach around the housing area can be reduced by the barriers. So you build the barriers with a small opening. Okay, so we already know the size of the slit is actually plays the main important thing, okay, in the diffraction. So if you want to make it, when you want to decrease the energy more, so means you have to make the size of the slit smaller, okay. So you have to build the barrier with a small opening so the diffraction can occur. So this one, the energy of wave will be spread out to a larger area after passing the gap, okay, and will be reduced. So the amplitude will be decreased. Okay, so the next one, the diffraction of water wave produce calm of water regions suitable for docking of ships and also for the water recreational activities. So here, right, so when this is the gap, okay, and this is the barrier. So when the water wave travel through the barrier here, the energy will be spread out, okay, the energy will be spread out, the wave will be spread out. So then the amplitude will be decreased. So here at this part, the water is more calm. Okay, and then for the next one, an audio frequency generator connected to a speaker, okay, and placed near the corner of a wall. Three students, A, B, and C, are standing around the next corner. The generator and the speaker can produce sound at the same speed but different frequency. Okay, when the high frequency sound is generated, only student C can hear the sound clearly. Okay, so if you use the high frequency sound, you can only hear, only the student C can hear. But when you use the low frequency of sound, okay, all the three students can hear the sound clearly. So explain the situation. So this one, if you want to explain, you can use the formula V is equals to F lambda. So F is actually equals to V over lambda. Okay, so when you use the high frequency, so the frequency is high. So what happened to the wavelength? The wavelength will be decreased. So means the wavelength of the sound now is decreasing. And you already know the diffraction is depend on two factors. The first one is the size of the slit or barrier. The second one is the wavelength. So if you want the diffraction to become more obvious, so you need to have the higher wavelength. So here when you increase the frequency, then the wavelength will be decreased. Of course, the effect of the diffraction of sound also will be decreased. So that's why only student C, okay, only student C can hear because the sound is less diffracted. Okay, why? Because you decrease the wavelength. Since you increase the frequency, now the wavelength is decreased. Okay, but let's say now you decrease the frequency. So when you decrease the frequency, what will happen to the wavelength? The wavelength will be increased. So when the wavelength increase, the defect of diffraction also will be increased. Means there will be more sound will be diffracted. So that's why the student A, B, and C can hear the sound clearly when the frequency is lower because the wavelength is increasing. All right. Okay, so this is the reason. So the frequency is inversely proportional to wavelength. So this is actually based from the V is equals to F lambda. So high frequency, the short wavelength, so it's difficult to diffract. Only C can hear, okay, and sound will easily diffracted when long lambda, okay, long wavelength. So all three students can hear clearly. Okay, so the next one, owls are able to communicate across long distance in the forest because they have long wavelength hoods to explain. So the sound of the owls will diffract through the space between the trees, okay, in the forest. So the longer the wavelength of the hoods, also easier to be diffracted. Okay, and another one is for the elephants, okay. So the infrasonic wave produced by elephants have long wavelength to facilitate, okay, long distance communication between elephants. Okay, so this one because and then another one is the diffraction of light. So this one can produce the hologram which are used of safety features on bank cards such as debit and credit card. So this one also they use a diffraction of light. Okay, so we already finished about the diffraction of light. So now I want you to answer the questions. Okay, so which of the diagram below shows the water wave which pass through a small gap correctly? Okay, three more. Who is it? Before that, do you have any question to ask about the diffraction of wave? Okay, so remember there are diffraction of wave, water wave, light, and also sound. Okay, that we already learned. Okay, Kenya? Sorry, you still, oh, I thought you still like. Okay, so which of the diagram below shows the water wave which passes through a small gap correctly? So of course the answer is C. Okay, it will produce the circular wave. Okay, very good. Are you clear about the diffraction? Anything you want to ask teacher? Even why you answer A? A is what? No, this one is for the, this one already said small, right? Okay, so before I move on, can you understand about the diffraction of wave? Sound wave, water wave, another one is a light wave. Okay. They don't have any formula for the calculation for diffraction. Okay, no formula. Only for reflection, yes. Refraction also yes. And interference later. Okay. Alright, so the next one. Okay, Viresh, Chushan, Kenya. Who is 27989? Hey, Kenya. Okay. All right, so it says, which phenomenon explain the propagation of water at X? So this one, it passed through the rock. So the rock is actually acting like a barrier or the obstacle. So of course, this one is a diffraction. So the answer is C. Oh, okay, it's okay. Yeah, why your answer is C? It should be C because it passed through the rock there. Okay, passed through the barrier. Okay, so this one name the light phenomenon involved. So this is called as a diffraction, all right, when it passed through the gap here. So it says a diagram 4.1 shows the pattern formed when seen through the gap of two fingers. So let's say if you put your two fingers, okay, stand like this, okay, and there's a gap here that then you make the light pass through. So that one we call it as the diffraction. Okay, so for this one, okay, for B1, wait for a moment. I want you to draw, okay, I want you to draw, okay, I want you to draw. It says here in the space provided above, draw the pattern formed when the gap size between two fingers is decreased. So we already learned the diffraction of light, right? So what happens when the size of slit is increasing? Okay, what will happen to the size of the fringes in the middle? Will it be smaller or will it be wider? Okay, so this one I want you to draw. Okay, based from here. Okay, 4 student already submit. What happened to the size of the fringes, okay, that in the middle, okay, whether it will be wider or it will be like more smaller. Okay. Siobhan, Jayu, Yvonne, Caroline, Zishan, Rachel, Yumin, Jayu, Junhin. Yeah, give 1 more minute. Okay, thank you. All right. Teacher, I don't submitted already, but I haven't drawn my answer. I drawn the wrong thing. Okay. All right, never mind. Yeah, you said the slide just now. Oh, yeah. Okay. So actually, when you remember when you see the video just now, right? So when they increase the size of the slit, okay, the bright fringes, okay, that in the middle, it become narrow, right? So here it says it decrease, right? It decrease the size of the slit. So of course, in the middle here, okay, the size of the slit, the size of the fringes here will become increase. Okay, this one should be increase. Okay, so never mind. And this one, I just did the here. Okay, this one should be. Okay, so this is the answer. Okay, so let's check your answer. Okay, as long as I can see the center, okay, the fringes at the center, the size of it increasing, yes, the answer is correct. Right. This one you draw for this one, right? So actually this for this. Okay. This one is wrong. I thought when you decrease the size of the slit, of course it will be increasing, right? So later we will see this one is wrong. This one is so wrong. No, it's not decreasing. Okay, right, right, right. What is this? Chinkiat. Why the size of the size of the dark fringes become smaller? It should be increased, right? So later we see. We let you. Okay, this one is correct. Okay, and then wrong, correct, wrong. This one like Junhin. Okay. I might put it in the. Oh, this one I think I clicked twice, right? So actually we already did. So let's see the diffraction of light. Okay, which is this light? Wait for a moment. This one, right? So you can see the size of the slit increasing, okay? 0.02, 0.04, 0.08, 0.16. You can see the bright fringes in the middle, right? It becomes smaller. So when the size of the slit increasing, okay, the size of the fringes, okay, the size of the fringes will become smaller. Okay, so most of you got it wrong. So can you understand that one? Can you understand that one that I just explained why your answer is wrong? It should be the increasing the size of the fringes at the middle there. For M, can you understand why your answer is wrong? Okay, thank you. Okay, here what will happen to the amplitude of the light after it passed through the gap. And for C, you have to explain why the phenomenon in 4A is more difficult to observe with light wave if we compare to the sound wave. This one already discussed for B3 and C. I already explained why it's more difficult to see the effect of diffraction for the light wave, okay, if you compare it with the sound wave. Teacher, can teacher send the PowerPoint later in group? I think we only have the notes until water diffraction for gap. Is it? Anyone else? Oh, really? Okay, okay, sure, sure. You want me to send in the group, or I will put in the Google Classroom? You want me to put in Google Classroom or in the group chat? Group, okay. I'm sorry, maybe. Okay, so Mickey, Yvonne, Erin, Honzen, Yvonne, Caroline, Zishan. Yvonne, Caroline, you okay? Okay. Right. So let's discuss the answer. So it says here, what happened to the amplitude of the light after it passed through the gap? Okay. So anything that passed through to a gap, okay, if the diffraction occur, of course, the amplitude will be decreased. Okay, so the amplitude will be decreased. So explain why the phenomenon in 4a is more difficult to be observed, okay, with light energy compared to the sound wave. So as we discussed before, okay, the light wave have the smaller wavelength, okay, if we compare to the sound wave. So when they have the small wavelength means it will be less diffracted. Okay. And this is the explanation for this one, right? Because it is 2 mark. Okay. So amplitude decrease, so the energy decrease because it spread out to the larger area after passing through the gap. So this one is actually for this, for the answer B2. And see this one. So wavelength is a light is smaller than the sound wave, so light is difficult to diffract. Okay. So let's see your answer. Decrease sound wave easily can be okay. For this one, you have to make, if you say this one only, I can give you 1 mark. Okay. So you have to mention that why is hard to be diffracted because of the wavelength, right? The wavelength is smaller. Okay. No. You have to mention about the wavelength. Okay, good, Junkiat. Mm-hmm. All right, very good. Ethan, you didn't answer for C. Trees. So what wavelength is small? Light wavelength? Okay, sound wavelength. So it's not clear. No, this is not why, because the light travel is, this one is decrease, is it? Okay, very good. No, it's not because light travel in the straight line. It's because of the wavelength. Mm, you have to mention about the wavelength. Okay. Um, light wave is shorter because it's proportional to wavelength. No, you have to just mention the wavelength of the sound wave is higher, so it will be easily to diffracted if you compare with the light wave. So you have to mention about the life, the wave, the wavelength. Okay. Mm-hmm. Mm, mm, there's another one. There is no change in amplitude. There is of course the change in amplitude. Every wave that pass through the gap, okay, or the barrier, there must be a amplitude change. Okay. Wait for a while. I need some time to. Alright. Okay, sorry. Okay, so the next one it says diagram 5.1 shows an audio generator connected to a speaker. So diagram 5.2a and 5.2b, okay, shows the diffraction of sound wave from the same speaker when sound of a low and high frequency are produced respectively. So the question said, what is the meaning of the diffraction? And another one, you have to mark and label the wavelength with lambda. Okay, for this one, for B, you don't need to do because this one you need to draw, right? So you cannot draw, of course. So you just give me the meaning of diffraction. Okay, just answer for A only. Okay, 5 more. Okay, how? Oh, sorry. So what does it mean by diffraction? Actually, it's the spreading of wave, okay, after passing through a gap or round of the barrier. Okay, so that's the meaning of the diffraction. Okay, the next one you have to mark and label the wavelength. So one wavelength is actually this one. This is also called a lambda. This one also lambda. This one also lambda. So you can measure either these three, okay, that I just put in the diagram here. So the spreading or bending of wave when the wave propagate through the slit or side of barrier. So that's the answer, the same like mine. Okay, which was spread out. Okay, very good. Okay, spread out. Okay, spread out. Very good. Okay, good. This one maybe you want to put a slash, right? Okay, so I think this will be the last one. Okay, then we will stop. So you have to compare the wavelength and also compare the shape of diffracted sound wave. Okay. Okay, Mickey, Sivan, Ziying, Caroline, Rachel. Okay, so let's check your answer. Okay, so compare the wavelength. Okay, so here you can say 5.2a. The wavelength 5.2a is higher than 5.2b. Okay, compare the shape of diffracted sound wave. So the diagram 5.2a is more circular. So the shape the wavelength for diagram 5.2a is more circular. Okay, so that's the answer. Okay, more curve. Okay. You have to put the shape. So means it means sorry, circular. Okay. No. Okay, correct. More curve. Okay. No. Should mention. Okay. If you mention the word circular, I will curve or narrow slit. No, we compare the wavelength, not the slit. Wait, A is shorter. I thought A is higher, right? Rounder, okay. Okay. Mention about the sequel. Okay, very good. Okay, so I think I will stop until here. So we continue next week. Okay. So after this, I will put the slide in the group. Okay. So thank you, class. Okay, only one slide yet left. Okay. So tomorrow next week we go to interference. Okay. So thank you. Okay. Stay safe, everyone. So see you on Thursday for presentation. Okay. Bye.